So what this video is going to be looking at is molar volume calculations. That means relating the moles of particular substance, say 1 mole of particular substance, and how much space that substance is going to take up. Now before we get into the calculations, just a couple of things that we need to address. First thing, you'll notice that all of these calculations involve gases: carbon dioxide, oxygen gas, chlorine gas. When we look at volume calculations, they will always be done for gases. So that's the first thing to note. The next thing to note is that you will see these letters STP seen frequently here. STP, STP, so all the problems have somewhere along the line the letters STP there. So we're going to look at what that is, and then we'll look at the conversion factors for it. So what we're going to be doing is looking at moles and volume and relating the two together. Let's start off with this idea of starting with gases. All molar volume calculations are going to involve gases. So let's just say we have, hypothetically speaking, a balloon here. And in this balloon we have 1 mole of a gas. That 1 mole of gas is going to occupy a particular amount of space. Now this STP stands for standard temperature and pressure. Why do we have standard temperature and pressure? Well, if we have 1 mole of a gas inside of this balloon and we change the temperature, or at least the temperature is not constant, it's constantly fluctuating, even though the amount of particles in here will always be the same, the amount of space it takes up will vary. Same thing with pressure. Even if we have the same number of particles in here, if the pressure is constantly changing, the volume will change. As a result, we want to find a correlation, or at least the relationship between moles and volume. We have to have a standard temperature and pressure. At standard temperature and pressure, what we find is that 1 mole of any gas, regardless of whether it's oxygen or if it's carbon dioxide or if it's chlorine gas or any gas, will always occupy 22.4 liters of space. So given that, you can see from this right here that we can get a conversion factor, which is 1 mole over 22.4 liters, or 22.4 over 1 liters over 1 mole. So let's take a look at the first problem. At STP, how many moles would 14.09 liters of carbon dioxide occupy? Well, we're given liters, so that's our start, liters. We want to convert to moles. Okay, so let's start off here with our given information. Let's start off with our given here, which is going to be 14.09 liters of carbon dioxide gas. Since it is at STP, we know that we can make a relationship between liters and moles. What is that relationship? Well, because we have liters here, we want to get rid of liters, so we'll put that diagonally here. We want to convert 2 moles of CO2, so that goes up top here. What is the relationship? Well, 1 mole is equal to 22.4 liters. Once you have that set up, calculate 14.09 divided by 22.4. If you look here, because this right here is a conversion factor, that's infinite number of significant figures, therefore your final answer has to have 4 significant figures. Final answer would be 0.6290. That's 4 significant figures, and that's moles of carbon dioxide. Okay, it's that easy. If you're having trouble with it, you're overthinking it. Okay, let's take a look at the next one. How many liters? So we want to end up at liters, and we're given moles, 6.18 moles of oxygen. So given that, let's take a look. We're given moles, and we want to convert to liters. How do we do that? It's going to be 6.18 moles of oxygen. And because we have oxygens up here, we want to get rid of it, so we will put it diagonally down here. We want to convert to liters, so we put liters of oxygen up here. What is the relationship? Well, at STP, 1 mole of any gas is equal to 22.4 liters. Alright, take a look here. Your start value has 3 significant figures, therefore your answer should have 3 significant figures, giving you 138 liters of oxygen. That's simple. Okay, so let's look at another instance. Let's say we were to do something a little bit different. Take a look at number 3. It says, what amount of space would 0.046 moles of chlorine gas occupy at STP? Let's say we put a prefix there, say deci, D. So again, in this instance, we're starting off with decimoles. We want to convert ultimately to amount of space being liters, unit being, we want to convert to amount of space, which is volume, and in this instance we'll just convert it to liters. So how do we do that? It's going to be decimoles to moles and then to liters. So let's start off with our given amount of 0.046 decimoles of chlorine gas. Because we have decimoles of chlorine gas here, we want to get rid of it, so we'll put it diagonally here, converting to moles of chlorine gas as such. Now once we have this set up, This gets to 1 because it has a prefix, and deci is 10 to the negative first. Next we have moles over here, so we want to get rid of moles, so we'll put moles down here. So we want to convert to liters, so we'll put liters over here, and it's 22.4 liters for every 1 mole. Therefore it'll be 0.046 times, it says 10 negative 1, you should be entering into your calculator 1 e negative 1, and then times 22.4. Answer for that should come out to being 0.10 liters with 2 significant figures, since the given amount has only 2 significant figures. So that's pretty much how to do molar volume calculations. It's pretty much that simple. This is the easiest out of all the calculations.